Assalamualaikum warahmatullahi wabarakatuh. Today I try to solve example of nozzle. Steam enter the nozzle at 400 degrees Celsius with a pressure 800 kPa, the velocity of steam 10 meter per second and the inlet area is 800 centimeter square. The steam will accelerate through this nozzle and the pressure and temperature drops to 300 degrees Celsius and 200 kilopascal. And the system will losing heat at a rate of 25 kilowatt. Therefore, I put it Q as a Q dot out. Okay. So the question is how to find velocity at the exit and how to find volume flow rate at the exit. So to find the velocity at the exit, I have to write down SFEE. Okay, so let's have a look at SFEE. Q dot in, I can cancel because there is no Q dot in, and nozzle, there is no work in nozzle. No potential energy, and this is equation SFEE equation at the inlet, and this is the SFEE equation at the outlet. So I divide all this equation with mass flow rate and I will get H1 plus C1 square over 2000 is equal to Q dot out divide with M dot plus C2 square over 2000. Okay, so now to get C2, I have to know the value of C1. The value of H1 and M dot. Okay, so M dot, as we know, this system has constant mass flow rate, which means M dot in is equal to M dot out. So M dot is A1 C1 over specific volume 1. So I have to know specific volume 1. How to find this property? Okay, so please be careful. For example involving steam, you have to identify the phase because we know for steam and liquid it has 5 phases. Phase number 1 is compressed liquid, phase number 2 is saturated liquid, phase number 3 is mixture, phase number 4 is saturated vapor, and phase number 5 is superheated. So we have to check the phase at state 1 and the phase at state 2. How to find the phase? Okay, so have a look at state 1. We have two intensive property given here, 800 kPa and 400 degrees Celsius. I want to find the phase. You can sketch TV diagram or PV diagram. So I choose to sketch TV diagram, and this is constant line pressure 800 kPa. I refer to table A5. And from table A5, I get T saturated as a 170.41 degrees Celsius. Okay, given here, temperature is 400 degrees Celsius, which means it is greater than T saturated. So, from here we know that the phase is in superheated. So, phase is superheated. Okay, if the phase is superheated, then I have to refer to table A6. From A6, I refer to 0.8 megapascal and 400 degrees Celsius of temperature, and I get H1 as 0.38, sorry, H1 is 3267.7 kilojoule per kg, and V1 is 0.38429. Unit is meter cube per kilogram. So I already have the value of H1 and specific volume 1. Next we go to state 2 because I want to find H2. Okay, H2. So here again I have to do the same procedure as I did in state 1. I have two intensive property, 200 kPa and temperature of 300 degrees Celsius. I don't know the phase, so I have to check with TV diagram. At P is equal to 200 kPa. I refer to table A5 and the temperature is 120 degrees Celsius. Given here 300 degrees Celsius, which means it is greater than desaturated. So I know that phase number 2, phase at state 2 is superheated. Then again, I have to refer to table A6, but I have to refer at pressure of 0.2 megapascal and temperature of 300 degrees Celsius. I will get H2 as 3072.1 kilojoule per kg and specific volume at Z is 1.3162 meter cube per kilogram. Please be careful with the unit. So I get H2. Okay. Next is I put all the value H1, C1, Q dot out, which is 25 kilowatt, M dot. Okay, so M dot here is 0.08. I convert centimeter square to M square. Multiply with 10 over 0.38429. And I will get M dot as 2.08. Okay, kilogram per second. Okay, and put all the value here. Then I get velocity at the exit as 706. No, not 700. 606. Okay, meter per second. Please be careful with the unit. Next, I want to find volume flow rate. Okay, volume flow rate is mass flow rate multiplied with specific volume. And I want to know volume flow rate at the exit. So, M dot is constant, therefore, 2.08 multiplied with specific volume to 1.3162. Okay, meter cube per kilogram, and this is kilogram per second. I will get as a 2.740 meter cube per second. So you please correct this answer to 2.740 meter cube per second. Thank you.